Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, we're going to look at some of the physical characteristics of group 1 elements. And of course, I'm going to combine this with some of the general discussion that we're going to look at, especially on the concept of abundancy and some of the concepts like electrode potential, and of course some of the physical characteristics like color and hardness we're going to see for group 1 elements. Now I've done this one intentionally so that in case we come across them, especially during the reactions, we're going to of course be able to pinpoint some of their characteristics, and these are going to assist us appreciate their chemical and physical characteristics which are mentioned in our introductory part. Now in this case we're going to look at various aspects of these particular properties. Now, I've listed the concept of atomic numbers, electronic configuration, atomic and ionic radii, electronegativity, ionization energy, the melting and boiling points, the electrode potential, density, hardness, color, and emission lines. And of course, these are going to assist us in trying to analyze some of the properties of group 1 elements. If we look at this one, of course, we are going to see that the atomic and ionic radii are going to increase down the group. And this is going to be witnessed through this specific trend from lithium, sodium, potassium, rubidium, cesium. And of course, we have not written francium, which we are going to mention in some way in some of our discussion. Now, in this case, from 152 to 265 and 59 to 70, there's a general trend of increase in this specific atomic radii and ionic radii. And this, of course, is going to be attributed to increase in the number of course, energy levels, which are going to be increasing down the group. And as we can see from this specific increase, there's going to be increase in relative mass. And of course, this is going to be given through this specific increase in numbers. And therefore, the increase in the number of protons, so basically, is going to increase the relative atomic masses of the respective elements as we go down the group. The relative atomic masses, of course, are going to increase, as I said, and of course the increase, and that's going to have an implication of increase in the atomic and ionic radii due to increase, of course, in number of levels. Perhaps I can give this one in terms of a summary. Increase in energy levels is going to increase both the ionic and atomic radii given as such. Of course, we're going to see that there is a specific, of course, trend as well that is going to be witnessed for ionization energy, which is going to be decreasing, of course, as we see from 520.2 to 375 across the group. And that is going to be attributed to increase in the number of shells. Now, in this case, we had said that the ionization energy is the amount of energy required to remove an electron from outermost energy level, and that is from the valence, of course, shell. Now, in that specific case, that one implies that this electron is experiencing some nuclear attraction forces from the protons, which are positively charged. Now, in case these specific protons are not holding the electrons with some strength, then therefore it's going to be easier for this electron to be taken away, and this energy involved is going to be referred to as ionization energy. Now, an increase in the number of shells, of course, is going to imply that there's going to be some shielding effect, which are going to be preventing these attractive forces from reaching the electron outside at this specific point, and therefore the forces required to remove this electron from the valence shell, then therefore it's going to be much more easier as we increase the number of energy levels. Now, since the energy levels are going to increase down the group, then therefore we're going to witness a decrease in ionization energy given as such. Now, if we look at the melting and boiling points for this specific group of elements for group 1, the melting and boiling points, of course, are going to decrease down the group, and this is because of the decrease in metallic character. Now, in this case, I've mentioned the concept of metallic character, and we have, of course, listed some of the characteristics of metals in some of our introductory parts, which is going to be assisting us in trying to, of course, describe this specific trend. So in this case, a decrease in metallic character is going to lead to a decrease in boiling and of course melting points. And this, of course, as we said, metals are going to be stronger and harder compared to non-metals, and therefore a decrease is going to lead to a decrease in both melting and boiling points across or down the group given as such. Now, if we try to look at this specific range for the quantities of the standard electrode potential in volts, these are going to be having large negative values towards the right. That is from up the group, from lithium, sodium, potassium specifically, and that's going to be an indication of the stronger or a strong metallic character or a good metallic character being displayed by these specific elements, and therefore these are going to be indicated using these large and negative, of course, quantities which are going to be given in terms of these negative values that we're going to witness. Now, the density for this particular group of elements for group 1 is going to increase across, or rather down the group. Now, the increase in density is going to be associated with the increase in mass to volume ratio. So therefore, we can indicate for this one as increase in density down the group is due to increase in mass to volume ratio. Now, remember, in our discussion about mass, volume, and other quantities, physical quantities, we have said that we can obtain mass as a product of volume times density. Now, in this case, if we are going to have density as our subject, then therefore we are going to have this one as mass of volume, which implies that an increase in this specific ratio, then therefore is going to imply an increase in density. Now, due to increase in the mass to volume ratio, then therefore that's going to have an implication of an increase in density down the group for this particular range of elements. Now, we're going to see that in terms of hardness as well, we're going to have a decrease. And of course, we're going to attribute this one to the softness which we had discussed in our introductory part in comparison between the group 1 elements, which was alkali earth metals and alkaline earth metals in that specific part. Now, we're going to mention this one, but as well, we had said that the attractive forces which are going to be witnessed due to an increase in the energy levels is going to cause some kind of a weakness, and therefore it's going to cause some of the metallic characters to be decreasing, and therefore that's going to cause these specific elements to be soft in nature. Now, we are going to also to look at some of the general aspects which we might come across in our various discussions, and those are going to assist us in trying to, of course, comprehend some of the physical and chemical characteristics that we're going to come across for these particular elements across or down the periodic table. Now, if you look at some of their general characteristics, of course, these group 1 elements, we're going to have lithium, sodium, and then potassium, rubidium, cesium, and francium. And in this specific case, we're going to see that in terms of abundancy, we're going to look at this one from perhaps an aspect of parts per million. And of course, we are going to compare this one in terms of the abundance, of course, with respect to some of the other elements that we're going to come across, or the entire concept of the periodic table. Now, in this particular case, in terms of abundance, we're going to have lithium in quantities of 18 parts per million, and then we shall have this sodium at 22,700 parts per million. And this is going to be 18,400 parts per million. This is going to be 78,2.6, and this is going to be trace. So there are some elements that we're going to refer to rare earth metals, which are going to be found in trace amount, and therefore these are the respective quantities which we're going to witness. Now, we can see from this one that sodium and potassium, in comparison with the other elements, are relatively abundant. And therefore, we're going to use this specific concepts in trying to, of course, appreciate their availability from their natural sources and some of the compounds that we're going to see. Now, these particular elements, of course, have got history, and we're going to see that Elements like sodium and potassium were discovered through the process of electrolysis. Electrolysis is the process of separation of these specific metals using some of the electrodes and of course some of the currents that we're going to see, especially under the concept of electrochemistry. Now in this case, of course, the two elements for rubidium and cesium, of course, which are going to be, of course, derived from some of the processing of lithium ores. We're going to talk about the concept of superdium, which is going to be spodumene. And the spodumene is one of the lithium, this is lithium, this is going to be a compound, perhaps let me just try to confirm for this. A spodumene is going to be a compound consisting of lithium, aluminium, and the silicate given as such. And the spodumene is going to be, of course, one of the compounds whereby we're going to use in trying to obtain what we call lithium. Now, in this case, sodium and of course potassium, as I've said, are going to be obtained from the process of electrolysis, or were discovered through the process of electrolysis, while cesium and rubidium are going to be obtained from the processing of this specific spodumene, and therefore they are going to be a product of the processing of this specific lithium, and therefore they are going to be obtained through these particular processes. Now for francium, this is going to be a trace element, as I mentioned, and this is going to be one of the characteristics of an element which is going to be radioactive, and it's obtained through the decay series, which is going to of course be a decay of octanium. So the decay of octanium, we have mentioned some of the decay series in some of our videos on the concept of course, radioactivity, and I'm going to put a link of a video in case we need to, of course, try to see where this specific element is obtained from this particular decay of this particular radioactive element. Now in this case, these are some of the sources which we're going to see being obtained, and of course the discovery of this one was from the emission spectra. As I said, they are going to be obtained through the processing of lithium, and then of course they were discovered through the concept of emission spectra, which is going to be given as such. Now I've intentionally left out this specific element of hydrogen from this group 1 elements, since we are going to see that hydrogen is going to display a very unique tendency in trying to of course undergo some changes like physical and chemical, and of course in forming some of the compounds that we're going to see, which are going to be molecular in nature. These are going to form covalent bonds, and of course I'm going to have an exclusive discussion in this particular case concerning this particular element of hydrogen. Now in our next discussion, we're going to look at some of the processes which are going to be involved, especially in terms of equations and some of the conditions which are going to be used in obtaining various elements which we have said for group 1 and 2. And perhaps those are going to give us a physical or an illustrative way of trying to describe some of the processes that are used to obtain these specific elements. So catch us in our next video, and kindly check our description boxes for various links of other similar videos which we are going to do. So that is it for now, guys. By God bless you. Catch us in our next video.